Jai Hind everyone, my name is Anupam Kumar Saini, Assistant Professor at Akgec EC Ghaziabad. In last lecture I discussed about the graph theory. In that lecture I discussed about various types of graph. I summarize in short way. In previous class I discussed about directed graph, in which in any graph if there is a direction between two vertices is shown, then known as directed graph, and undirected graph if the two nodes are without any direction are connected via H, then undirected graph. Loops and multiple edges. Loops means if both end of any edge is same, then it is known as loop, and multiple edges if more than one edge between two vertices, then these edges are called multiple edges or parallel edges. Various terminologies used in graph: degree of vertices, if degree of vertices if the number of nodes connect, if number of edges connected with any node is known as degree of that vertex. Here for example, vertex u is connected with two edges, then degree of this vertex is u 2. This is handshaking theorem, in which explain about the degree of vertex in term of edges. Summation of dvi equal to 2e. That is, if there is a graph whose vertex a, b, c, d, and degree of a plus degree of b equal to 2e. Here degree of a 3, degree of b is 3, degree of c is 3, and degree of d is 3. 2e, it means e equal to 12 upon 2, that is 6. This topics already covered in previous lecture, so don't need to in detail. Graph is a set of vertices and edges. Simple graph if there is no any parallel edge and self loop between any vertex, then this is known as simple graph. Multigraph if there is a parallel edges between two vertices, then this graph is known as multigraph. Weighted graph if weight is assigned between two vertices, then the graph is known as weighted graph. A weighted graph is one in which each edge is assigned a non-negative number weight called the weight of that edge. Weights are typically associated with cost, capacity, and distance or speed. For example, B and C having weight 3, C and D having weight 1, and C to A having weight 5, and B to A is the weight 2. This is complete graph. We represent complete graph by K, N. N represent number of nodes in that graph. K in a simple graph that contains exactly one edge between each pair of distinct vertices, means complete graph in which every vertex should be connected with remaining other vertices. This is a graph of three vertices, then this vertex is connected with this vertex is connected with, means each vertex is connected with other vertex in that graph. This graph is K4, complete graph of 4 vertices. Cycle forms if starting node and ending node are same, then the graph contains a cycle. Wheels. In a cycle, if we add one vertex, that is, in between a cycle, if we add one vertex and connect that vertex with other vertices, then this is known as wheels. As definition, Wn obtained by adding additional vertex to Cn and connecting all vertices to this new vertex by new edges, then this is known as wheel. If the graph is this, we add new vertex, that is, and connect with this vertex, all remaining vertex connected with this vertex, then this is known as wheel. Next most important topic is bipartite graph. In a simple graph G, if V can be partitioned into two disjoint set V1 and V2 such that every edge in the graph connects a vertex in V1 and V2, so that no edge in G connects either two vertices in V1 or in simple definition we can say that bipartite graph is a graph in which a graph is divided in graphs vertices are divided in two parts in such a way one end of edge should go with V1 and one end of edge should go with V2. For example, if we take this graph in which total vertices are V equal to A, B, C, U, V and W, these are total vertices, and if we divide these vertices in two parts, V1 and V2, in this A, B and C, it has UV and W. These are the vertices with V2 and these are the vertices with V1, and all edges are connected with V1 and V2 both. If we take this line to disconnect these graphs, then one end of this edge is go with V1 and one end of each edge go with V2, then the graph is known as bipartite graph. For example, if we in exam point of view there are various graphs shown and they say that find this graph is bipartite or not. If in exam this is a graph and ask for this given graph is bipartite or not, then the solution of this problem is graph coloring. In graph coloring we assign a color to each vertex in such a way that no two adjacent vertex have same color and minimum number of color to color this graph. If the graph is colored exactly two colors, then the graph is known as bipartite graph. In this graph, if we assign color to each node and if this graph is colored with exactly two color, then this graph will be bipartite graph. We see here that this graph is bipartite if we assign this V1 to with red color, then each node A, B and C will colored with red and V2 with white, all vertex of V2 assigned white color and all vertex of V1 assigned with red color. There we can see here that no adjacent vertex have the same color. A adjacent vertex A adjacent with U, V, then these nodes having color white, and A, B are not adjacent, then we can put the same color. Here in this example, if we assign this node with red and these nodes, node A, B, C, D, E, if we assign red color to A, then we can't give the same color to its adjacent vertex, that is E, B and D can't assigned with same color. Here we have to put different color other than red. If A has red, then E will be yellow, and the adjacent vertex of red is D, that should be also yellow because this node is not adjacent with D, is not adjacent with A. Now if this node is yellow, then B cannot be yellow or red. We have to put another color other than red or yellow. We assign B with white color and node C with red, because this node C is not adjacent to A. In this graph there is 3 color required for proper coloring, then this graph is not bipartite graph because it colored with 3 colors. If more than 2 colors are there to color any graph, then that graph will not be bipartite graph. Complete bipartite graph. As we see previous slides in which that complete graph, we see that about the complete graph. Complete graph are that graph in which all the nodes are connected with remaining all the nodes. Same for the same features, in this complete bipartite graph, each vertex of V1 and each vertex of V2 should be connected to each other, means V1 should connected to V2 and V2 should connect with V1. We can say that the degree of vertex V1 will be number of vertices in V2 and degree of vertex V2 will be the number of vertex in V1. Here we can say that V1, in V1 there is a vertex A and B, U, V, W, we labeling these graph, and we see that A is connected with V, U, V and W. Then degree of A equal to 3, number of nodes in V2, and degree of B, same, degree of B equal to 3, and degree of U equal to number of nodes in V1, that is 2. Here we can see that U connected with A and B, then degree of U is 2, degree of V is 2, degree of W is 2. Then this graph is known as bipartite graph. As definition, KMN represent bipartite graph. KMN represents bipartite graph in which M represent number of nodes in V1 and N represent number of nodes in V2. This graph is K23. KMN is the graph that has its vertex set portioned into two subsets of M and N vertex respectively. There is an edge between two vertices if and only if one vertex is in the first subset and the other vertex is in the second subset. Next topic, subgraph. Subgraph of the graph G is a graph H where vertex V is subset of the V and E dash is the subset of E. Here we can see that if any graph is there in G, if we take its some part as a graph, then this graph is known as subgraph of G. Means H1 is subgraph of G and H2 is subgraph of G. Here U, V and W are the vertices of G and we take a subgraph UVW and these two edges are also belong to G, then this graph is known as subgraph of H1 is known as subgraph of G and H2 is known as subgraph of G. G equal to G1 union G2 means we take union of two subgraphs, then we will get with a graph. If there is a graph of vertex UV and other graph of vertex WV, then common vertex is W, then we connect with W to U and W to V. Then this is a union of G1 and G2. We can say that G1 and G2 are the subgraph of G. Next topic is isomorphism. Isomorphism. There is a one-to-one and onto function f from V1 to V2 with the property that A and B are adjacent in G1 if and only if FA and FB are adjacent in G2 for all A and B in V1. Function f is called isomorphism. In other way, we can define in simple definition isomorphism in which isomorphic graph is that graph in which all the vertices and edges having the other second one graph. Here example, these are the graph, this having vertex u1, u2, u3, u4 and another graph v1, v2, v3 and v4. Both these graphs are isomorphic to each other because in this graph total number of vertices equal to 4. Here total number of vertices also equal to 4. Total number of edges in this graph are 4. Total number of edges in this graph are 4. And degree of each vertex is 2. Here 2. Here 2, 2. Each vertex has degree 2 in G1 and in G2 each vertex having degree 2, 2, 2, 2. in this graph also have each vertex having degree 2 and this vertex. Then as per definition 1 to 1 correspondence also there, means each vertex of degree same degree is connected with the same degree graph. In other example, take other example, if this is a graph A, B, C, F, G, means total number of vertices are there in this graph 1, 2, 3, 4, 5, 6, 7, B equal to 7, E equal to 6. We take another graph one, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6, 7. In this graph also 7 vertices, B equal to 7 and E equal to 6. Here we see that number of vertices and number of edges are same in both graphs. Now we see that 1 to 1 correspondence. Here we see that the degree of A equal to 1, degree of B equal to 3, 1, 3, 1, 3, 2, 1, 1. These are the degree of graph. This graph G1, we can name it as G1 and we take this name graph G2, and this graph having degree 1, 2, 3, 1, 2, 2, 1. Okay, in this graph we see that degree of in this graph we see that degree of this vertex is 3 and degree of this vertex is 3, and in this graph only this vertex having degree 3, none other vertex with having degree 3. Then there is a these two graphs are not isomorphic to each other because degree of the vertex are not same, means 1 to 1 correspondence relation are not here. These are the next topic, that is planar graph. I will discuss these topics in next class because of shortage of time. Planar graph and Euler graph and Hamiltonian graph. In next class I will discuss about planar graph, Euler graph and Hamiltonian graph. Thank you and Jai Hind.